Now we'll take this example. So we had sales done by 4 groups A, B, C, D, or 4 teams A, B, C, D, and with respect to months, which is Jan, February, Jan, Feb, March. Right? Suppose if you take this 50, that is the sales done by A team in the month of Jan is 50 lakhs, 50 crores. Right? So based on this data, suppose if we want to find if you want to test, is there any significant difference in the sales made by A, B, C, D? Right? So in that case, so we can use the previous discussion what we had with respect to ANOVA. By using F equal to MSTR by MSC, we can come out with a conclusion with respect to the testing of the significant difference in the sales done by 4 teams A, B, C, D. So, apart from this, if we want to find out, is there any significant difference in the sales with respect to the months here? Right? So with respect to Jan, Feb, March. That means here based on the same data, we want to test the hypothesis with respect to sales as well as with respect to months. Right? That is with respect to rows as well as with respect to columns. Therefore, we have to use the two-way ANOVA. Right? So by using two-way ANOVA, we can answer the two questions. That is there any significant difference with respect to sales done by 4 different teams, and also with respect to the months Jan, February, and March. Okay. So we'll see how to do it. Now we'll try to solve this problem by using ANOVA. So here if we do this problem only with respect to sales, we have to find summation of x1 square, x2 square, like this. So one idea is like always to go with the sum of big numbers. We can reduce it to small number. This is one idea. Okay. Suppose instead of 500, if you had 500, 5000, then we need to square the larger numbers. To avoid this, one idea is, so you can make all the entries into smaller ones so that the computations become smaller. Here what I have done is, I took the small one number, that is 40, and I subtracted each from 40. Each number and minus 40. So here 50, now 50 minus 40, 10, 46 minus 40, 39 minus 40, like this. So now what I do is, I do all the calculations based on the modified numbers, like shown in 10, 6, minus 1, 10, 0, 8, 4, 8, 10, 0, minus 1, 5, minus 1. Right? This is not compulsory. If you feel that I have to do with larger numbers, you can convert them into smaller numbers by subtracting any constant number from each and every entry. Right? Now what we are doing is, we consider the modified numbers 10, 6, minus 1 and do all the calculations what we are doing. Right? So now, like what we have done earlier with respect to single way ANOVA. So first we calculate the T, that is sum of x1, sum of x2, sum of x3, sum of x4, like this. That is column wise. Right? So that's why it is 15 plus 12 plus and so on, it is 48. Then immediately the correction factor, that is t square by n. Now in this is similar to what we did in case of one way ANOVA. We calculate SSTR, that is summation x1 square by n1, summation x2 whole square by n2, summation x3 whole square by n3, and so on, minus correction factor. Right? So then we get SSTR, that is 42. Sorry. Next, so here whatever we have done, it is with respect to columns, like what we have done with respect to single ANOVA. Now we do with respect to the rows, that is SSR, sum of squares between the months, that is here rows. So now it is 17 square, that is same way here with respect to rows we are doing 17 square by 4, 29 square by 4, 2 square by 4, and so on, minus the correction factor. So we get SSR, that is 19.5. Next we calculate SST, sum of squares total. So then we got 216. Now we calculate SSE, which is sum of square total minus SSTR and SSR summing together. Now we'll have various degrees of freedom. One is degrees of freedom with respect to rows, with respect to columns, and also degrees of freedom on the whole, that is R minus 1 into C minus 1, that is 6 here. Now we can sum up all the values whatever we tried. in this form. So here, so between the salesman, that is between rows as well as between columns, like, so between salesmen, whatever calculations what we have done is SSTR as well as C minus 1, and also MSTR, which is SSTR by C minus 1. Similarly, between months, that is between rows, we had SSR as well as corresponding degrees of freedom, that is R minus 1, and also MSR, which we can have with the help of SSR minus R minus 1. Then we got this 45.75. And also we had the calculation with respect to residual errors, that is sum of square errors what we had, and also corresponding degrees of freedom, that is C minus 1 into R minus 1, that is 6, and MSE, mean square error, that is SSE by corresponding degrees of freedom, that is C minus 1 into R minus 1, we had 13.75. Now we had all the corresponding values to find F values, MSTR, MSR as well as MSE. Now here we need to have one note, that is if MSTR is less than MSE, then we use this to find F value. If MSTR is greater than MSE, then we use F equal to MSTR by MSE to find the F value. Now, so we'll have to find F value with respect to columns as well as with respect to rows. Now, with respect to the salesman, that is with respect to treatment, if we take here MSTR is greater than MSR, it is MSTR is greater than MSE. Therefore, we use MSTR by MSE, that is 14 by 13.75, then we got F value. Now, similarly for the F value corresponding to months, that is blocks, it is 45.7 MSR by MSE, then we are getting it as 3.327. That means similar to one-way ANOVA, we try to have F value with respect to rows as well as F value with respect to columns. Next, what we have to do is we have to compare these two with respect to corresponding values that we had from the tables. Based on that, we will take the decision. Now we had two F values. One is F with treatment, that is with respect to sales teams. This is F value with respect to the sales teams. And this is with respect to blocks, that is with respect to the months what we had. And here, if you remember the beginning, where we are going to test the hypothesis related to sales and one more hypothesis related to months. So next what to do is, now with respect to sales, what we got is 1.018 with the corresponding degrees of freedom, that is 3 as well as 6. And similarly with respect to the months, with respect to rows, we got the calculated value as 3.327 with degrees of freedom 2 as well as 6. Next what we have to do is, so we have to go for tabulated values. We have to choose a corresponding alpha value. Suppose alpha equal to, it can be 5% or it can be 1%. Now from the tables, for a alpha selected, for these degrees of freedom 3 and 6, we have to see what is F value. Right? And similarly, for this degrees of freedom 2, 6, for the level of significance selected, we have to calculate F value. Right? So here degrees of freedom 2 as well as 6. 2 is numerator degrees of freedom and 6 is denominator degrees of freedom. So then, like what we did in case of the single way ANOVA, we have to compare the tabulated value with the value which we had here. So if 1.018 is less than the tabulated value, then the hypothesis is accepted, otherwise it is rejected. So here in this case, whatever the hypothesis we had with respect to the sales is accepted or rejected based on the relation between the calculated value and tabulated value. If the calculated value is less than tabulated value, we accept the hypothesis corresponding, otherwise reject. Okay. Similarly, so for months, for the rows, we got 3.327. Then we compare this 3.37 with the tabulated value with respect to the degrees of freedom and the level of significance we selected. Then we compare these two. So if the calculated value is less than the tabulated value, accept the null hypothesis or claim related to the months, otherwise reject. Right? So like this, by using two-way ANOVA, we can test the significance with respect to the rows as well as columns. Right? So try to understand the difference between one-way ANOVA and two-way ANOVA. So when to go for one-way ANOVA, when to go for two-way ANOVA. Thank you.